Hi everybody, welcome back to our channel Matho Techniques. Today we shall get into a new topic called sets. Okay, so what is the definition of set? Definition of a set is collection of any well-defined objects. Okay, in a particular, when you group a well-defined object in a particular form, that is called as a set. Okay, now any member or item of a particular set is called an element of the set, and it is represented by this E. Okay, so if you take, for example, if you take A is a set which has all natural numbers, so the natural number is an element of that set. It is an item or a part of that set. Okay, so that is how it is represented in this form, in this symbol. This is a symbol of element. Okay, next you represent a set in a particular format. Okay, it's either called as tabular or rooster format. Okay, so in this format, in this tabular format, you just define the set as this set is a, for example, A is a set of natural numbers. You just define the set just like that. Or B is a set of even numbers. You just define the set without giving any sort of a rule or any prerequisite for that set. Okay, so when you are defining something without any rule, it is called as a tabular form. But if you are setting some rule, okay, for the particular set, okay, so that is called as rule method or the set builder notation. So these are all synonyms again. So you should make a note of these synonyms, because you can be asked write this in a particular define or illustrate this in a form of a set builder notation. So, and they will give you an example and they'll say write it in the form of a set builder notation. So how is set builder notation represented? It's represented like this. So it says X A is an element of a set which is represented as X. Okay, and what is X? X is a natural number. The X is natural numbers, not number, it is plural. It is natural numbers wherein X is less than or equal to 5. Okay, so what is this? X is natural numbers. A is represented as a set of X, okay, where X are natural numbers and X is less than or equal to 5. So in this, what is the set? A can be defined as, so they will give you this, you have to write this as an answer. That's how it may be. So it is 1, 2, 3, 4 and 5. Okay, this is how you write the answer. So X is less than or equal to 5, they are saying. Okay, so even 5 is included. So all these numbers from 1 to 5 is the definition of this set. Okay, next B is defined as X, wherein X is a part of even X is even numbers. So that is a rule. Okay, that's a rule. First rule is what? It is a even number. Okay, and what is the second rule? Second rule is X is less than or equal to 10. Okay, so in this, what will be the set? So this is, they have given in the rule format or the set builder notation format. This is the thing. Okay, this is how the set builder notation is given, and this will be the answer for it. Okay, so what is, if they have given this and they have asked you to find this, okay, so they will, or if they have given this, they will give A is 1, 2, 3, 4, 5, write it in the represent this in a set builder notation form. So how do you represent? You represent it by writing like this. Okay, or they will give you next, let's solve this question. So X is B is an element of X, okay, wherein X is even numbers, okay, and X is less than or equal to 10. So what are even numbers? Even numbers starts with 2. So 2, 4, 6, 8 and 10. Why 10? Because it is X is less than or equal to 10. Okay, so the answer for this is this. Okay, so if they give you this and they tell you these are the set builder notation, find the answer for this. Okay, so this is the answer. Or they can give you reverse also. They will give you this and they will tell you, please represent this in the set builder notation form or rule method. Okay, so it can be asked either way. Or they can ask the rooster method also. That is very easy. You just need to write in words what it is. Okay, so here set of natural numbers. So A equals all the natural numbers starting with 1, 2, 3, 4, 5. It goes and on and on. And here set of even numbers. So B equals 2, 4, 6, 8. It goes on and on. So this is the answer. So they can ask this and ask you to write it in the tabular form, or they can ask this and ask you to write it in the set builder notation. Okay, so I hope you are clear. So this is how sets are represented. Okay, so you can have simple exercises in this in this format. Okay, so they will ask you, they will give you this and they'll ask you to write this notation, or they will give you this notation, they'll ask you to find the answer for that. Okay, so till here I hope you are clear. Now there are different types of sets. Okay, so what is first we shall discuss about finite sets. So finite sets are wherein there are well defined finite numbers are there. Means there is a starting point and there is an ending point. It doesn't go infinite, means it doesn't go to infinity. Okay, so there is a well defined start point, there is a well defined end point for it. Okay, so that sort of a set is called as a finite set. So there is a well defined finite numbers that are represented for this. So what is an example for it? For example, A is a part of a set wherein X is represented as even numbers less than or equal to 50. So you have a start point and you have an end point. Okay, the start for even numbers is 2 and the end point is 50. So every number, so in this the set is A equals 2 to 50, all the even numbers between 2 to 50. This is the answer for this. So this is a finite set, means there is a start point and there is an end point, a well defined start and a well defined end point. Okay, so if you know finite, what will be the opposite of finite? Infinite. So what is infinite? Where it is not well defined. So as a representative of the same example, if A is represented as such that X is an element of even numbers. So they are just telling X is all even numbers. So that is infinite. It can go to infinity, right? So A is 2, 4, 6 and it goes on and on and on. Okay, so that is the even numbers. I mean, that is an infinite set wherein it is not well defined. There is a start point but there is no end point to it. It goes on and on and on. It goes to infinity. Okay, so I hope you are clear on finite and infinite. Now we shall see what is an empty set. Empty set is something which does not have any items in it at all. You define it but no items will come into it. For example, X, A is represented as X. X is equal to 0, but X is a natural number. 0 is not a natural number. So there is no number which represents like this. Okay, or if they say X is such that it is even numbers from 2 to 10. Okay, but X is a odd number. So how can you mix those two? They are two different things. You cannot get odd numbers and even numbers together. Like they are totally two different. They are in two different zones. Okay, so therefore these are empty sets wherein there is no items that belong to it at all. Okay, it's an empty set. Now when I define empty set, I will also tell you what is an equivalent set. Okay, I have not written equal set, so okay, I will tell you what is an equivalent set. Equivalent set is wherein the items are, the number of items that is there in that particular sets are equal, means the number of items. Now for example, if you say A is represented such that X is less than or equal to 10 and X is all even numbers, and B is represented such that X is less than 10 but X is all odd numbers. So A is defined as those items which are even numbers less than or equal to 10. Okay, so what are the even numbers less than or equal to 2, 4, 6, 8, 10? 5 items are there. Okay, so in this 5 items are there. What are the 5? 2, 4, 6, 8 and 10. Okay, so there are 5 items in this. Now B is represented as less than or equal to 10. That is one of the rule. But X is an odd number here. So if that is an odd number, what is it? 1, 3, 5, 7, 9. So these two sets A and B are equivalent to each other. Why? Because the number of items that are there in this is the same. Okay. So this has 5 elements and this also has 5 elements. So when the number of elements are the same in two different sets, it is called as equivalent set. Now if you say A equals ABC, if a set is having A, B, C as defined as A and B is having defined as X, Y and Z, okay, still they are equivalent sets. Why? Because the number of elements, there are 3 elements in B, 3 elements in A. So number of elements that are there in each of these sets are the same. So therefore they are equivalent sets. Okay. So I hope you are clear till here. There are more types of sets that we have to discuss. As this video is going longer and longer, I will divide it into different videos so that you get a thorough understanding of what I want to elaborate every type of set so that you understand it clearly. I want to give you examples so that you understand it more clearly. So we shall end this video at this juncture. I shall continue in my next video with the different types of sets in my next video. I hope to see you in the next video. Thank you for joining us in this video. Kindly do consider to subscribe our channel so that you can support us and you can get notification from our channel whenever we upload a new video. We are uploading almost every day, so that it helps the students to understand and be in touch with the subject. So mathematics is something which you need to be in touch with always, on an everyday basis, so that it gives you that confidence to deal with numbers. So that is the reason we upload almost every day. Please do kindly go check our playlist also so that you can see every topic in the form of chapters that are seen in your exercise book. So for example, if you take a single, for example, this, now I'll put this sets also into a playlist. So you can see introduction of sets, then you have types of sets, then I will go to more other types of sets, then you have certain theorems that comes. So all that I will describe, and then I will go to exercises so that you can see how it comes in your exercise book. So when there is a person who is explaining it, how you see it in your textbook, you can understand it better, you can get more thorough knowledge of that subject. So we shall see you in the next video. Thank you for joining and have a great day. Bye.